Greetings everyone, my name is Ahmed, currently enrolled in the Energy Systems Master Engineering program. Today I'm excited to guide you through our project titled Utilizing Lehigh University Assets to Participate in Demand Response Programs. Our project team is composed of two members, my colleague Mohamed from the Energy Systems Engineering program and myself. Before delving into the details, we extend our sincere gratitude to the project sponsor, DERNetsoft, particularly Alberto Colombo, CEO and founder of the company, and the project management team comprising Oshan and Javin. Their guidance has been instrumental throughout the project's duration. We would also like to express our appreciation to Professor Rudy Shankar for his unwavering educational support, which has significantly contributed to the success of our project. Furthermore, a special acknowledgement and thanks goes to the project leader, Mr. Doug, from Lehigh University Facilities Department for his invaluable contribution to the project progress. In the upcoming slides, I will give you a quick rundown of the project, covering its goals, background, and the methods and tools we have used. After that, my colleague Mohammed will take over. He will dive into the technical details, share the results we have achieved, and outline our plans for future work. This way, we will make sure to cover all aspects of our project in a clear and concise way. Starting with the project description, walking through the project scope, let me introduce a brief introduction about the Demand Response Program. Demand Response Program refers to balancing the demand on power grids by encouraging customers to shift electricity demand to times when electricity is more plentiful or other demand is lower, typically through prices or monetary incentives. Demand response is an important source of flexibility for managing the impact of variable renewables and growing electricity demand on stability and reliability of the electricity grids. More details and explanation will be introduced in the following slides. So, our project scope aims to assess Lehigh University capabilities to participate in demand response program. This scope is divided over 2 semesters' work. Running semester involves investigating how Lehigh University could leverage its current assets, specifically emergency generators, to actively take part in various PGM demand response programs. The next semester work will include the visibility of establishment of virtual power plant for the campus by capitalizing on existing distributed energy resources and its enhancement for exploiting any opportunity for improvement. Talking about project objectives, this semester project goals aim to have a thorough understanding and solid knowledge of demand response program, components, and tools, and conduct a technical and economical study for Lehigh University participation in different components of demand response program. Consequently, assess and examine the revenue stream for concerned participation in different programs. Ultimately, this will lead to cost reduction for electrical bills, as we will demonstrate in both capacity and energy charges. Talking about the background of the project, uncovering the drivers and motives for this project, Lehigh performs a demand response activity on a voluntary basis to reduce capacity and transmission load ratings that are assigned to Lehigh electricity accounts each year. By using building automation system to reduce consumption during peak loads, which is in summer periods. Lehigh University has been enrolled in an emergency demand response program for many years. This program is run by PJM Interconnection, which is the local power grid operator. Historically, this program required Lehigh to reduce its peak summertime electrical demand to a predetermined level, for example 10.5 megawatt, when operating at a higher level such as Lehigh typical peak load, which is about 14 megawatts, when called upon to do so by BGM to prevent brownouts or blackouts from occurring on the power grid. In addition to the required emergency demand response program events, Lehigh implements some of the same strategies on a voluntary basis to reduce capacity and transmission loads that are measured during these events. As it will be shown in more details in the following slides, the cost of capacity and the transmission charge is around $1.5 million, which is a major drive for cost reduction. The potential for this cost reduction could be derived from utilizing the existing emergency generators. Talking about the methodology, tools and techniques which have been used, our approach started by gathering the electricity bills and contracts for the main university accounts from the last 2 years. This helped us figure out when the demand for energy is the highest and understand the big charges that Lehigh pays each year. We then have studied BGM demand response programs to learn about their requirements and see which ones Lehigh is already a part of. Beyond that, we explored other PGM programs that Lehigh hasn't joined yet, but could benefit and seeing potential benefits in participating. At the same time, we looked at Lehigh University emergency generators. We made a list of what's available and picked up the ones that can be used to lower the campus energy use during events related to demand response programs. In simple terms, our plan involved looking at past bills, studying BGM programs, finding new opportunities, and making smart choices with the emergency generators to help Lehigh save energy and money. And the following slide is a breakdown structure of the project showing the 3 main pillars of the project: the background research on demand response program, the second one is collecting electricity bills, and the last pillar is contracts and on-site emergency generators assessment. In the following slides, my colleague Mohammed will walk you through over the slides to demonstrate about the project technical results, future work details.
Thank you, Ahmed, for illustrating the project description, objective, and background. Let's start with the technical discussion on the project. As discussed in previous slides by Ahmed, the main objective of the project is to increase the Lehigh University participation in the demand response program. So firstly, we should understand the demand response program, how it's work, and its benefits. At its core, demand response is a consumer-driven strategy enabling individuals to curtail electricity consumption at their location, particularly during times of high wholesale prices or when the reliability of the grid is under threat. Now, let's explore the compelling benefits of participating in the demand response program. First one is lowering wholesale market prices. One of the primary advantages of the demand response program is the ability to lowering the wholesale market pricing by voluntarily reducing energy consumption during peak demand periods. Consumers actively contribute to a more balancing supply and demand equation, mitigating the needs for expensive backup power source and subsequently reducing the whole sale prices. Second one is the grid reliability. Another essential benefit is the positive impact on the grid reliability. When electricity demand surges, for example, during extreme weather event, participants in the demand response program play a vital role by voluntarily reduce energy consumption. They help stabilize the grid, preventing potential disruption and ensuring reliability electricity supply. The third benefit is generating revenue. Perhaps one of the most compelling aspects for participants in the demand is the opportunity to earn revenue by load curtailment during demand response event. The fourth benefit is a sustainable solution. Demand response is not about the cost saving, it's also a sustainable solution. By encouraging energy users to be mindful of their consumption pattern, we collectively reduce the environmental impact associated with electricity generation, aligning with broader sustainability goal. But this goal is not achieved in our project in the first phase, because we are going to use Lehigh University natural gas generators to participate in the demand response program. In the next semester, we could achieve the sustainability goal by making a study for participating in the demand response program by virtual power plant. There are steps should be followed by user to participate in every demand response program. Firstly, the user should be signed up for voluntary reduce energy usage during extreme period. Second, electricity demand surge triggered for instantaneous by extreme weather event. The third step, participants actively reduce their energy consumption during their peak load. The fourth step is the collective reduction in the demand response help balance supply and demand, stabilizing the grid. The last step, the participants are compensated for their curtailment by reducing the peak demand during the event. So in conclusion, the demand response program is a win-win, providing a consumer with a mean to reduce their load and sustainability energy is the future, while also offering financial incentive for their participants. It's a collaborative effort that empowers individuals and strengthens the resiliency of energy infrastructure. This table provides a comprehensive view of different terms and factors associated with demand response program, showing programs that Lehigh University enrolled in. There are 5 types of demand response provided by BGM: the capacity demand response, the peak demand response, ancillary service, frequency regulation, and economic demand response program. And each program has its criteria that should be fulfilled to participate in these programs. Now Lehigh University participates in the capacity and demand response programs, but it's only participated by reducing 500 kilowatt from the demand using existing building automation system, by lowering the air conditioning system temperature setting during the published event. The project goal is to increase Lehigh University participation in the capacity and energy market by using the existing backup generator. As shown in the table, Lehigh University couldn't participate in the ancillary service and the frequency regulations in the current phase of the project because the notification lead time is very small and it's aimed to control the grid frequency and the voltage at short time. But in next semester, we will make a feasibility study to participate in those programs using a virtual power plant and energy storage system. Firstly, we should understand the difference between capacity and the energy market. In the capacity market, there is a commitment from the user to participate in the published event. It's paid based on the daily rates such as the capacity and the transmission charge. In the energy market, the user gain revenue from supplying amount of energy when the energy prices in the day ahead or real time is very high. BGM capacity market is called reliability pricing module, and it's aimed to ensure grid reliability by securing the appropriate amount of power resources needed to meet the predictive energy demand. Lehigh University can reduce its electric charge in the next years by reducing the peak load measured during published event, as will be illustrated in the next slide. As shown in the graph, we collected the electric bills for the big electrical account of Lehigh University. This result showing the main substation account is the biggest account to contribute in the Lehigh University electrical consumption by approximately 92% from the total consumption, so that all the project analysis and results are based on this main account. Lehigh University yearly consumption is around 62 gigawatt hour. In the left trend, showing the breakdown prices for Lehigh electricity bill along the past 2 years. Yearly, Lehigh University pay around $6 million in electrical bills, with $1.5 million in the capacity and the transmission charges. And this is the area of our project focus on. The right trend showing the university consumption per months along the last 2 years. And it's clear that the big demand for Lehigh University occurs in the summer periods. And so, by big demand reduction during this period, Lehigh University could achieve a revenue. Lehigh University has emergency generators that could be utilized to participate in the capacity market to reduce load during published event and gain revenue, as will be shown in the next slide. Lehigh University has around 62 backup generators in different buildings, and this table showing the selected generator to participate in the demand response programs, with agreement with Lehigh University facility, based on the connected load criteria to avoid any disturbance on the campus. The selected generator connected to emergency load of each building, so it could feed only 50% from its rated power without modification. To participate in the demand response program, we should firstly calculate the operational marginal cost of the generators. From the generators datasheet, we calculated the operational marginal cost, which is around $0.3 per kilowatt, as shown in the table with the red highlighted numbers. This trend is showing the variation in the energy prices in different zones. The yellow curve is showing the Lehigh University zone. The curve showing that the charges per megawatt per day is changes. The prices are going high, which means a potential saving in the capacity and the transmission charges. We're reducing loads during peak load and during the grid node congestion. This table showing the historical curtailment event published during the last years, with Lehigh University load during those events. The university load was around 12 megawatt hour. The capacity and the transmission load measured during the five highest peak load hours each year are used to set the electricity rate for those type of load that Lehigh pays throughout the following year. By getting Lehigh University usage during last years and comparing the peak load during event, we can estimate the potential revenue from participation in the capacity and transmission in the capacity market. We estimate two scenario: if Lehigh University turn on generator to reduce peak demand by 0.5 megawatt, we could achieve revenue around $72,000 per year, reduction in the capacity and the transmission charges of the next year. And also, if peak demand reduced more up, if the peak demand reduced more than 0.5 megawatt, for example 1 megawatt, it could achieve more reduction in the capacity charges by $138,000 per year. The second potential is to participate in the energy market when the real-time prices are high, as will be shown in the next slide. In this case, the potential revenue will be the achieved hourly reduction in each hour multiplying by the energy prices at those hours. Those trends showing the variation in the real-time prices along the year. The red trend is for the real-time prices, and the green lines is for the day-ahead market prices. The red spikes in prices showing the potential revenue from participation in the capacity market by running the emergency generator. During those periods, the university could gain a revenue from the load reduction. And for the next, we will discuss our project results. Our project result could be concluded as showing in the slide. Lehigh University could invest $35,000 as initial cost to obtain permits from Pennsylvania Department of Environment Protection and modify the existing building automation system to be able to run generators and reduce load during event. And by this investment, potential revenue will be around $102,000 per year, which means that the return on investment will be almost around 4 months. But by running the generators, Lehigh University will increase the CO2 offset emission by 5.2 metric tons CO2 equivalent, which has a negative impact on the environment. For the project future plan, what's the next? The project future plan is enhancing the participation of Lehigh University in the BGM demand response programs. This includes selecting building assets for virtual power plant simulation, analyzing utility data, and add more distributed energy resources. The plan focuses on providing insights to improve the university engagement in demand response programs, enhance grid resiliency, and achieve Lehigh University net zero goal. Thank you for your attention, and we are willing to answer any question we might have. Thank you.